Okay, so this lesson is for anybody that had trouble with the lesson in class on using the trigonometric laws to solve one of these vector questions. I should point out right away, never try to use a trig law method to solve a 3-vector question unless you really want to get a lot of practice using your trig laws and triangle rules. It's going to be a long, tough haul if you try that. But with 2 vectors, it's actually often a little more compact and convenient and even easier than using components. So components for anything with 3 or more vectors. For 2 vectors, you can use the components method or the trigonometric method. So we're going to use the trig laws this time. Again, we have a 25.5 kilometer vector going east 35 degrees south. This is the example that's in your handout. Followed by one that's going 65 degrees north of east for 41 kilometers. And here's the diagram that we worked out in the last problem that shows the resultant that we're trying to get. So the first thing we have to do is we have to figure out what we need for the cosine law, which is a squared equals b squared plus c squared minus 2bc cos a. Where capital A and small a are the angle and side opposite to each other. We're trying to solve for small a, which is our resultant. So when we write this out, we're going to need r squared equals 25.5 squared plus 41 squared minus 2 times 25.5. Oops, let's move that. 25.5 times 41 times cosine of A, where A is this angle right here, because it's opposite the value we're trying to solve for. Now, the problem we have is we don't know what A is yet. However, using angle laws, angle rules, if you have 2 parallel lines and a line running through it, there are a lot of similar angles here. This angle and this angle are the same, as well as this angle and this angle. And these 2 angles are the same, and the same as those 2 angles. So there are ways to figure out what these angles are. Since this angle here is 35 degrees, this angle here has to be 35 degrees. And since this angle is 65, right here, we know that the 3 angles, 35 degrees, 65 degrees, and A, come out to a straight line, which is 180 degrees. So A is 180 minus 35 plus 65, which gives us an angle of 80 degrees for A. So we have all these values up here. This A up at the top right here can become 80 degrees. And when you plug that in and solve for r, not r squared, but r, you get 44 kilometers. So that's a lot quicker than using the component method to get the length of that. It's maybe less complex if you don't know the laws, but if you have a cheat sheet like you will on the unit tests, no problem. Step 2 is to figure out what the angle is for the resultant vector. Let's call that theta. So to get theta, we need to know, the only way we can get to theta, I should say, is if we can figure out this angle here. Call that alpha. Because alpha is 35 degrees plus theta. I'll write that over here. So okay, so we figured out that alpha is equal to 35 plus theta. Now we just have to figure out what alpha is in order to get theta. And to get alpha, we use the sine law. We know that the sine of alpha is this angle here, divided by 41 kilometers, is going to be equal to sine of the one angle we know, A, which is equal to 80, over its opposite, which is the resultant, which is that 44 kilometers. Now, I'm writing 44 kilometers. You should keep the value in your calculator that you got when you solved this equation up here. It's not exactly 44. Okay, so keep the full set of decimals just to make sure your angle calculation is accurate. There might be a rounding problem. If it's really close to halfway, you can run into trouble. So we solve this, and we get alpha. Let's take 2 steps here. Multiply both sides by 41 to get sine alpha equals 41 sine 80 over 44. And without punching it into a calculator, didn't have one with me for this lesson, without punching it into a calculator, when you solve for alpha, I believe you get around 66.5 degrees. 66? No, 60.5. Sorry. 65.5 degrees. I know I just said 3 numbers there. I'm sticking with this one. When you subtract that, or from, when you take that value and plug it in here, 65.5 minus 35 equals 31.5. 30.5, I should say. And I think it comes out to just over, there are a bit more numbers after the 5, so it rounds up to 31 degrees. And so, again, like in the component method, we get that R equals 44.1, I think, kilometers east, 31 degrees north. Check to make sure that agrees with the other one. Plug in your own calculations, finish this your own way just to make sure, and you should be in good shape.